Thank you. I would refute that metaclasses are the Python equivalent of quantum mechanics. This talk is advanced in the sense that you need to know quite a bit of other stuff about Python before you can understand it, but it's not advanced like quantum mechanics in that only 2 people in the world can understand it. So I'd like to say thank you to all the organizers. Before I get going, everything's been really well sorted out for the speakers, and it's been a really easy conference to come and talk at. I'm based in the UK. You can probably tell that by my accent. If you can't understand what I'm saying, please put your hands up and throw something at me. I work as a freelancer in Cambridge and in London. I do mostly Python, and within Python... Hello, is that better? Good, thank you. I do mostly Python work, and within Python I do mostly Django. I first gave this talk at DjangoCon in Warsaw earlier in the year. And while the examples I'm going to use come from Django, you don't need to know Django in order to be able to follow along, I hope. So, the purpose of this talk really is twofold. I want to discuss what metaclasses are and how they work, and I want to talk about what they're useful for. Oh, thank you. Okay, good. So, purpose is twofold, talking about what metaclasses are and how they work, and then what they're useful for and how how Django can make use of them. So, at the end, I'll ask for questions. I'll also ask for any feedback you've got. I think it's really useful as a speaker to be told what you did well and what didn't go so well. Finally, we're going to be using Django 1.4. This isn't the most recent version of Django, but there's a good reason that we're using this for the examples, and that will become clear, I think, towards the end. So let's begin with a few examples from Django. I had a client who has got and he looks after ponies, and he wanted a web application that allows him to keep track of who the ponies are in his farm. So we've got here a pony form class with the usual name, color, and birthday fields. And if we look at this class, it's got an attribute called base fields on the class. This attribute is a dictionary of all the fields that are defined in the class. And at first sight, you might think that base fields was being calculated as a sort of a class property when we look up the attribute. But in fact, base fields is in the class's internal dictionary. So when the class is created, something does some work to add an extra attribute to the class. And this is a metaclass doing the work. My next example. So the farmer was very pleased with his pony tracking application, and he asked me to extend it to track animals like horses and donkeys. So I decided to create a Django base class, a Django abstract base class, and you can see that this is done by setting the abstract property to true inside the class called meta. Now, before going any further, I want to say that Django models and forms have this inner class called meta. This is not a meta class. It's just a really unfortunate name collision. Anyway, this equine base class has got this class called meta, except that I've made a spelling mistake. And rather than writing abstract, I've got abstract. And straight away, I get an error message. So the error message is saying class meta got invalid attributes abstract. So again, something is getting involved when the class is being created, and it's doing some work. And in this case, the metaclass is telling us that our class definition is somehow defective. So my third and final example, the farmer was very pleased with this application once I'd fixed the spelling mistakes. And he wanted to add a new feature whereby he could keep track of which stable each pony belonged to. You could say he wanted a stable API joke. So we define a class, a model called stable, and if we instantiate it, we might want to look up which ponies belong to this stable. But of course, we get an error message, and the stable object has no attribute pony set, and that's because we've not told stables anything about ponies or ponies anything about stables. So if we rewrite our pony class and we add a foreign key to the stable model, suddenly the same stable instance has got access to a pony set object. And if this was wired up to a real database, we'd be able to look up all the ponies that belong to a particular stable. So again, this pony set attribute has been added to the stable class at the point that the pony class was created. So again, the ponies metaclass has got involved here and has done some work for us. So I've examples of what metaclasses can do for us. It's time to start examining how they actually work. But before that, we want to just do a quick recap of what classes are themselves. So this should all, I hope, be sort of familiar territory to you all, so I'm going to go over this quite quickly. So here we've defined a class called SumClass. It's got a class attribute and it's got a method which takes a value and sets an instance attribute to that value. What we do with classes is we instantiate them. So we use them as factories for creating objects. So here we've instantiated SumClass, and that gives us an instance of that class. And we can check in Python if you've got an object and you know what it is. What you're really asking is, what class does this object belong to, or even really what class was used to create this object. And we use the type function to find out what class was used to create the object. So in this case, the type of instance is the SumClass that we've just created. Now, classes themselves in Python are objects. So we can check, we can see is SumClass an instance of object? And it is. And in Python, if you want to know what an object is, you can ask for its type. So we can ask for the type of SumClass, and the type of this class is type. So this perhaps is strange if you've not seen it before, but we'll explore the motivation for this as we go on. But the important thing to remember is that the type of a class is type. So one exciting thing we can do in Python is we can create classes dynamically. So we're used to creating classes, I guess, statically by writing them with the class name, some base classes, colon, and then a class body in a Python file. But we don't have to do that, and that's in fact syntactic sugar for the way of creating classes dynamically that I'm going to demonstrate now. So if we have a name of a class and a tuple of base classes and a dictionary of attributes, so I should probably have reminded you that methods in Python are just attributes of a class where the value happens to be a function. So this dictionary of attributes is actually a dictionary containing a single method. But given a name and some base classes and some attributes, we can call type with three arguments: the name, the bases, and the attributes, and that creates for us a class. So we can check what the type of this class is, and it tells us type. So if you remember from the last slide, the type of a class is always type. So this is good evidence that creating the class as we've done here works. But Python is what we call duck typed, and that means it's more important if you've got an object to know what you can do with the object than to know what class it is. So what we do with classes is we instantiate them. So here we've instantiated the class we've just created, and indeed the init method does get called. So again, this is good evidence that we've created a class which is equivalent to creating a class as we would do so normally. Yes. Stuff. So this is exciting because we can control how classes are created. And here's a function that is called create class. It takes the name and the bases and some attributes. And in the block where it says we can do anything here, we really can do anything here. So we can fail if we decide that the arguments that have been called with are somehow invalid, or we can change the value of name or bases or attributes so that we create a class with some extra behavior, or we can do anything else. So let's see an example of that. Let's see an example of creating a class dynamically. This function here is called create form class. It takes a name and some attributes. And the important bit is these two lines here. So in the first line, we iterate over all the attributes, and we find any which are instances of field, and then we create a new attribute in our attributes dictionary called base fields, whose value is this dictionary of fields. So if we call create form class with our pony form attributes again, we get back a class, pony form, and this class has got the base fields attributes set as we would expect. So is that making sense? Good, thank you. I think I'm probably going through this quite quickly, so if there are things you want me to slow down and explain again, do say. Okay, so here's the most important slide in the whole presentation, and the question is, what is this type thing we've been talking about? So, as we've said in Python, if you want to know what an object is, you call type on it. And when you call type on type, you get back type. Now, this is slightly problematic because, in fact, type is two things in Python. It's the function which takes a single argument that tells you what class an object belongs to. But also, we've seen that it's you can call it with 3 arguments, and that's the form of type that we're using here, it turns out. Now, we've seen that any object whose type is a class. So that means that type that takes 3 arguments must be a class. And we've seen that when you call type with 3 arguments, you get back a class. So it's a class that's used for creating classes, and so we call it a metaclass. Clear? Here's Mud. Good. So Nicholas, who's on the front row, has written an even less clear description of what metaclasses are in the style of explaining the rules of cricket to a foreigner. I'll let you Google that for yourselves. Anyway, so type is a class, and one thing we can do with classes is we can subclass them. So we can subclass type. And here I've subclassed form type, and I've overridden the under new method. So what under new does is it gets involved when an instance of the class is created. And what this under new method here does is exactly the same as our create form class function earlier. So it pulls out the fields from the attributes, and it sets a base fields attribute to be that list of fields. and I can demonstrate again that this works. I would recommend, if you've not seen Metaclasses before, that you find either the code for this talk on GitHub or another explanation of Metaclasses, and put a bunch of print statements in, and see when the print statements get hit, and see what the value of things like name and bases and actors is at various points in the class creation cycle. Just a demonstration that the base fields has been set up as expected. So in Django and elsewhere in Python, we use metaclasses whether we realize them or not. But never do we, or very rarely do we call a metaclass directly itself. So here, we called the metaclass to instantiate it. Very rarely do we do that ourselves. Instead, you can specify the metaclass to use when creating a class in the class's body. So here is a definition of the form class, and it's got this class attribute called under metaclass, and that tells Python when it's creating this class called form, use the form type metaclass to create it. And what's important here is that the metaclass gets used for all subclasses of the class where it's defined, or sorry, where it's specified. So we specify the metaclass form, but the metaclass of pony form is also the metaclass of its parent. And as we've seen before, the base fields attribute gets set. So that's kind of all there is in a nutshell to how metaclasses work. They're used in 4 or 5 places in Django. So we can have a look here. We've got examples in, well, the 3 most important metaclasses, I guess, are the declarative fields metaclass, which does more or less what our form type metaclass did, in that it takes a form object and it pulls out the fields which should go on the form, and that allows things to render the fields of the form in order, for instance. Then there's the model form metaclass, which does something similar for model forms, but the most important and most interesting and probably the scariest bit of code, or one of the scariest bits of code in the whole Django codebase, is this model base metaclass. And that's what gets involved when you create models. And it does all the stuff to do with validating that models are correct and setting up the relationships between different models and more. So it's a few hundred lines long, but it's worth, I guess, stepping through in a debugger and just working out exactly what it is doing. So what's next? Python 3. Did you want that for your slide? Sorry. Good. Python 3 things are a bit different. Now, if you remember at the start, I said we were using Django 1.4 for this example. And that's because in Django 1.5, Django 1.5 supports both Python 2 and Python 3 on the same codebase. And metaclasses are implemented slightly differently in Python 2 and Python 3. So in Python 2, you specify the metaclass as a class attribute on the class. In Python 3, you give the class a kind of a keyword argument to specify the metaclass. Now, this change is useful because it means that the metaclass can get involved with how the class body is handled. So in Python 2, the metaclass gets given a dictionary of class attributes. But sometimes you might want to have the order of attributes in the class body to be significant. And in fact, in Django, the order of the fields in a model are kept track of, but Django has to Django's got a global counter that keeps track of how many fields it's seen. So if you've got a class body, it knows that the first field in the body might be the 200th field to be defined, and then the next one might be the 201st, and the next one might be the 202nd. And so it uses this slightly hacky machinery to keep track of the order of the fields. In Python 3, the metaclass can say, let's treat the class body as an ordered dictionary, and so that makes it, I guess, easier to keep track of the order of fields. There are other probably less obvious uses or reasons why having the metaclass in advance before you read the body of the class is useful. But actually, I couldn't think of any good examples while coming up with the slides for this talk. Nonetheless, in Django 1.4, it uses Django 1.5, where it's got the same code base for Pythons 2 and 3. It uses a library called 6 to handle sort of incompatibilities between Python 2 and 3. And it's, sorry? I think that will come back by itself, I hope. I'll keep talking. Good. If you look at the 6 library and see how it handles metaclasses, that would give you, I think, a good understanding of how metaclasses work and what they do. So, what next? Pitfalls. Yes, metaclasses are great. They're powerful, but you can sometimes shoot yourself in the foot. So this first example came from some real code that I was working on a few weeks ago, and it didn't become apparent until the code was running on a customer's production system, and debugging was quite tricky. So I'm going to give you sort of a basic version of what the problem was. Here is a decorator, and you can use it to decorate a function, and it just prints out that the function has been called. So we use this a decorator like this to log every function call in a program, and to log what it was called with, and to log its return values. But in this case, it just prints out that the function has been called. So we can use it like this. We can decorate a function called calculate, and then when we call calculate, it just prints out that calculate has indeed been called. You can also use this decorator to decorate methods in a class, but doing so for every method in every class gets tedious. So you can write a metaclass that will look at all the attributes in a class, and it will see if the attribute is callable, and if it is, it will decorate that attribute with the trace decorator. So here's where we iterate over every attribute, and we check whether its value is callable, and if it is, we update the attributes dictionary to be the decorated value of the callable. And that's fine, that's good, that works almost all the time. So here's a calculator object. Its metaclass is the tracing metaclass. And you can see that when we call, or rather when we instantiate it, we see that init gets called. Yeah, that's useful. When we call the calculate method, we see that the calculate method has been called. So this is very useful, and it saves typing. But here is another class. This class delegates its calculation to the calculator. So you see that it's got a class attribute which is itself a class. And the calculate method, first of all, instantiates this class, and then it calls a method on that class. And this doesn't work. So when we instantiate it, that's fine. When we call calculate on it, we get back an utterly unhelpful error message. And it's complaining about a problem in our decorator up here. It's saying that this line here, this function takes 2 arguments, and it got 3. Now, the problem here is that when when the tracing metaclass gets involved with creating the calculation delegator, one of the attributes that the class has is this class attribute whose value is a class which is callable. So this calculator class gets decorated, and I think it's probably easier for you to go away and step through with a debugger to see exactly what's going on, rather than me sort of explaining step by step, because I'll just end up saying the word class about 50 times, and I've already said it too much, I think. So that's just one thing to be aware of. Obviously, the way we had to deal with that was to check that the callable wasn't actually a type. And in fact, it got more fun because we had old-style classes, which I've not talked about and I won't talk about in there as well. Probably what would have been better to do would be to check that the value was a function, and then to whitelist the things which we could decorate. So that's just one thing to be aware of. That's just demonstrating the fix. The next pitfall, we've got one metaclass here. We've got another metaclass here. In the first case, we've got a class called class 1, which is whose metaclass is metaclass 1. And then when we create class 1, we see that this print line here has been called. We can do the same with class 2. That's all fine. These metaclasses don't do anything at all, really. They just demonstrate that they've been called. But if we have a class 3, which inherits from both class 1 and class 2, Python doesn't know what to do with the metaclasses, and it gives us a type error. So it says there's an error when calling the metaclass bases. There's a metaclass conflict. The metaclass of a derived class must be a non-strict subclass of the metaclasses of all its bases. I'm sure there's an all your base belong to us joke in there somewhere. The problem here is that we've got 2 base classes, both of whom have metaclasses, and those 2 metaclasses don't know how to cooperate. So this means that you've got to be extremely careful when dealing with a situation like in Django where your models have a metaclass. You've got to be very careful that if you introduce your own metaclass in there, that your own metaclass knows how to handle the model-based metaclass that Django gives you. I don't think I've ever seen a situation where having sort of 2 inheritance chains of metaclasses really worked out well. So I'd probably avoid that. And that brings me on to the Zen of Python. So I'm sure you've all seen import this. In fact, is it on the t-shirts this year? Probably, yeah. So import this. That doesn't quite fit. How about that? Here are some general guidelines or principles for writing Python code, and a few that I want to bring out in particular. Explicit being better than implicit. So it's always better to be explicit about what your code does. And when you have behavior tucked up inside a metaclass, and where it's not always obvious that a metaclass is involved, I think you're hiding code and you've got implicit behavior, which is perhaps not desirable. Also, readability counts. I guess that's the same point. Because you can have a metaclass on a base class, and then you subclass the base class, and it's not clear that the metaclass is involved on the subclass, you lose readability there. There was one other I wanted to point out that said perhaps you should use metaclasses somewhere. I think actually metaclasses are quite beautiful. Classes being objects themselves is nice. You've got this sort of unifying formulation for how classes work. And I guess that's beautiful, but I can't see the point that I was going to make. So let's move onwards. So just a few things to take away. We know that classes are factors for creating objects. Metaclasses are factors for creating classes. Metaclasses allow us to control how classes are created. And finally, metaclasses are hard. So I think that means thank you very much. Good. So any questions? Of course.
Have you seen any framework for combining metaclasses? When you've got metaclasses doing different things, how do you make them work together?
So the question was, is there a framework for combining metaclasses? I've not seen one. Has anybody else? No, I guess not. I think to do so would to introduce more complexity into your code than it's worth. But yeah, it might be quite fun to try and hack one together. The other fun challenge I was going to suggest, we know that metaclasses are classes that create classes. Can anybody come up with a useful metaclass, which is a class that creates a metaclass? I've tried. I can't think of anything sensible that you could do with that, but I'd be interested to see any good examples. But going back to your question, I don't think there is a framework for doing that.
Hi. Have you ever used Metaclass to something else besides than their new method? Because usually when you write a Metaclass, pretty much all you do is overwrite a dunder new method, and that's it. That's where your magic is. Have you ever done anything else?
Correct. So the question was about whether metaclasses ever do more than just override the under new method, which is used to create the class. I've not. In Django, in model base, that's a big metaclass that's got a bunch of methods, which I guess are helper methods for under new. I guess, so metaclasses being classes, you could subclass them and have some kind of funky inheritance tree where behavior gets sort of spread out across different classes. And that might be a good use for methods other than under new. But yeah, I've not seen that often. Oh, okay. I see. Okay, so in Python 3.4, there's a new implementation of, yes, a brand new implementation of an enum class, and that uses some metaclass magic, and that does have stuff outside the under new method, I think.
A simple question: does each metaclass has to be subclass of type?
Correct. Yes. So if you try and specify a metaclass which is not a subclass of type, I think you get a type error. There's one at the back. I type really fast. So I've got a tool called PresCons, which is a presentation console, and you give that a file which contains your Python code, and as you press the spacebar, it steps through the code and executes it for you. And that's on GitHub as well. So in fact, all the code is there. And I'm catching up with my wife on Twitter. So if you want to follow me, I'm at Inglesby.
I see there are no more questions, so thank you very much.
Thank you.